A very good morning to all of you. I cordially welcome you all for this applied thermodynamics course. So in the today's class, we are going to discuss about the high pressure boilers. So some of the important high pressure boilers are the Benson boiler as well as the Lamont boiler. So the motivation of the today's class is to know the working principle of the Lamont boiler and Benson boilers while you are selecting a boiler for a given application. So the outcome of the today's lecture is, so at the end of the class, you should be in a position to explain the working principles of the Lamont boiler and Benson boiler with the help of the need sketches. So that is, I've already told you that in the second unit we are having the boilers. So the schematic diagram is very important one. So that's why you should be in a position to explain the working principle of the Lamont and Benson boiler with the help of the need sketches. And I've already told you that the Benson boiler and the Lamont boilers are basically the examples of the high pressure boilers. So let us know first of all, what do you mean by high pressure boiler? So whenever the steam generation capacity is above the 80 bar, then it is known as high pressure boilers. So where you find the applications of these high pressure boilers are in the present days, most of the modern thermal power plants are basically using these type of the high pressure boilers. So what is the working principle of the high pressure boilers? Here you can, because this particular paragraph is basically giving you the information about the working principle of the high pressure boilers. That is, if the feed water pressure increases, the saturation temperature of the water also increases and the latent heat of the vaporization will be decreases. So because of which the feed water can be heated to the saturation temperature in the economizer. Because we know that what is the basic function of the economizer means, in the economizer we are having the feed water. So this particular feed water will be heated with the help of the waste flue gases which are leaving through the chimney. So because of which the efficiency of the plant will be increases. So that is only lesser amount of the heat will be supplied from the boiler, because you know that efficiency is equivalent to output by input. So here the input value is normally lower. So because of the lower input from the boiler, so the efficiency value will be increases because of providing the higher pressure boilers. And what are the features of this particular the higher pressure boilers? So that is, these are the forced circulation water normally there, because we know that the boilers are classified into the natural circulation and the forced circulation, but these are normally the examples of the forced circulation. And here we are having the larger number of the smaller diameter tubes will be there, and higher steam pressures and temperatures you are able to generate from the high pressure boilers. So automatically the improved mode of the heat transfer, so because of which the efficiency will be high, improved method of the heating. So pulverized, instead of having the chain grating mechanism, so here we are having the pressurized combustion mechanism we are having, and they are very compact, and they will give you high efficiency, intensive heating, and once through construction. So these are the salient features of the high pressure boilers. And what are the advantages of the high pressure boilers? So that is, they require very lesser heat of the vaporization. That is, so far whatever the features we discussed here, lesser heat of vaporization, that is a very less amount of the heat input is required in the boiler. So because of which heat input will be less and efficiency will be high. So they are very compact and requires less floor space, and due to high velocity of the water, the scale formation is minimized. So it is a very biggest advantage, because the scale formation is the biggest problem in the most of the thermal power plants due to the scale, that is the scale formation in the water. So that is the hardness of the water will be very high. So always we have to send, that is only the, we have to remove the scale formation, and the feed water treatment is the biggest method we are adopting in the any thermal power plant. So that is the removal of the scale formation, and because of this pumping of the water with the higher velocities, the scale formation is basically minimized, and all the parts are uniformly heated, and the danger of the overheating of some of the parts are basically minimized. The steam can be raised quickly to meet the variable load requirements without the use of complicated control devices. The plant efficiency will be increases with the use of the high pressure. The steam generation is very economical. And these are the brief description about the advantages and characteristic features of the high pressure boilers. Now let us go to the one of the high pressure boiler example is here it is the Lamont boiler. So what are the advantages of the Lamont boiler? That is always I told you that the smaller diameter tubes are normally used in these high pressure boilers because of which higher heat transfer rates are maintained. So the multiple tube circuit gives the flexibility for suitable location of the heat transfer equipments, and automatically here we are using the forced circulation of the water through the tubes and higher evaporation rate is achieved. And go to the schematic diagram of the Lamont boiler. So here you can see the most of the accessories, that is the superheater, and here we are using the evaporator. So this is the feed water circulation pump, and here it is the steam drum. So it is the feed water circulate like this. So here the flue gases are basically going like this. That is here the flue gases are coming in this particular direction, and they are passing through the superheater, economizer and air preheater. So here you are having the superheater, here you are having the economizer, and here you are having the air preheater. So that is the whatever the flue gases which are leaving from this particular combustion chamber, so they are giving up its heat to the superheater, to the economizer, to the air preheater. So finally giving up its heat to all these particular one, then they are leaving through this particular the chimney. So that is the biggest advantage of the Lamont boiler because of adopting all these particular the accessories. So similarly, it is known as the Benson boiler. It is known as the drumless. The Benson boiler is also known as is a drumless boiler. It is the one of the basic characteristics of the Benson boiler. It is also high pressure, that is supercritical, that is above 221.2 bar. It is greater than 221.2 bar pressure it will operate. So that's why it is a high pressure supercritical boilers. Is a drumless, once through is a water tube boiler. So just you can see here the operating pressure is a 250 bar, more than 250 bar. That is here you can compare. So it's a 221.2 bar is the critical pressure, and it is operating with 250 bar. So 250 bar is normally higher than this particular the 221.2 bar. So it is a once through boiler. That is why it is called as the once through boiler, means the feed water enters one end of the tube and comes out of the superheated steam from the other end. So that's why it is called as a once through boiler. So just you go through the diagram of the Benson boiler, and here you can see the Benson boiler thermal efficiency will reaches to 90%, and it will generate the 135 tons of the steam per hour. So just very higher steam generation capacity, and it can be started within 15 minutes. Normally the boilers will take several hours to start, but here it can be started within 15 minutes to produce the required flow rate of the steam. So here you can go through the advantages of the Benson boiler. So very lesser floor space, and weight is also less, 20%. It can be started or stopped at very quickly. Parts can be transported very easily, and it can be assembled also on the side without any problem because there is no drum, and it can be operated economically, and the explosion hazards are basically minimized in this particular the Benson boiler. So the same, that is the line diagram always will remain same. So the flue gas, because it's a furnace, so it is the flue gases are basically flowing like this. So here it is economizer, air preheater, and these are leaving through the chimney like this because the feed water, the water is coming in this particular direction to the economizer. Always economizer, the inlet is the feed water, and here the economizer outlet is the hot water because the flue gases are coming in this particular direction. So the atmospheric temperature of the water is basically increased because of transferring the energy from the flue gases which are leaving through the chimney. So like this the Benson boiler will works. Now let us see some of the important competitive examination questions which were given in the previous examination. That is, let us deal with the first question, IES 1999. So there is no steam drum in which of the boilers. So just now we discussed the Benson boiler, there is no steam drum. So which one of the following statements is not true for a supercritical steam generator? Not true. So go through the ABCD options. So it has a very small drum compared to the conventional boiler. So we told you that supercritical steam boilers are not having any drum, but he is saying that smaller drum. Actually, there is no drum, so there is no meaning of the smaller, larger drums. So similarly here, 1, 2, 3, 4 is given. So what are the correct sequence of the entry of the water through these particular the components? That is the radiation evaporator, economizer, radiation superheater, convection superheater. So just you go through the diagram, schematic diagram. So now you can answer the C, that is the correct sequence of the water in the Bunsen boiler is the economizer, radiation evaporator, radiation superheater, and finally convection superheater. So just you go through this one, the Bunsen boiler schematic diagram. Yes, so this is, so that is, it is a radiant water heater is there, convective superheater is there, transient heater, economizer, and then chimney. Now he is asking the flow. Now the same thing. So here C, that is 2134, that is it is the economizer, then it is the radiation evaporator, radiation superheater, and convection superheater. So then it is the assertion and reasoning type of the questions will be normally given in the IAS and IES examination. So assertion is Bunsen boilers is much lighter than the other boilers. Boiler pressure rises to the critical pressure in the Bunsen boiler permits doing away with the steam drops. So here, which options are correct? So both A and R are individually true, but R is also the correct explanation of the A. So the answer is A. So like this, we are able to answer some of the questions based on the Bunsen boiler as well as the Lamont boiler. So thank you very much for listening this important lecture on the high pressure boilers. Thank you.